Hello everyone, good evening. So here we shall start from question number 13 onwards. So here it is given that E and F are respectively the midpoints. E and F are respectively the midpoints of the non-parallel sides. The non-parallel sides AD and BC of trapezium ABCD. Trapezium ABCD. So I can say that obviously AB is parallel to DC. So hence it means if we draw the trapezium, ABCD, and E and F are the midpoints of AD and BC respectively. So this is equal to this is equal to this, since E and F are the midpoints, and AB is parallel to DC. So we can join EF, and then we have to prove that EF is parallel to H. That's the first part. And second part is we have to prove that EF equals to half of AB plus CD. AB plus CD. Here what we can do, we can do one construction. We can join DF and extend it to meet AB extended at the point G. Here we will add one construction. The construction is line segment DF is drawn. DF is drawn, which meets line DF is drawn and also extended to meet AB produced at the point G. Then the proof is like this. The proof is, we'll say that in triangle DCF, and triangle GBF, in triangle DCF and triangle GBF, let's see that angle DFC, that is equal to angle DFC. Angle DFC is equal to angle GFB, since they are vertically opposite angles. Since vertically opposite angles are equal, and also angle CDF, that is equal to angle CDF equals to angle BGF, and these two angles are equal. Since why? Since DC is parallel to AG, and so alternate interior angles are equal. And also CF equals to BF, since it is given that F is the midpoint of CD. So therefore I can say that, so we have used two angles. So we have used two angles, this angle and this two. And we have used that the non-included sides are also equal. So therefore triangle DCF is congruent to triangle GBF. DCF and GBF are congruent by AAS rule. By AAS rule of congruency. IP is full of congruency. So therefore, I can say that DF equals to GF, DF equals to GF, DF equals to GF by CPCT, and also uh, DF equals to GF by CPCT. Okay, here, and also CD is equal to BG, and also CD equals to BG. CD equals to BG by CPCT. So now, therefore, we can see that in triangle DAG, in triangle DAG, F is the midpoint. F is the midpoint of F is the midpoint of DG, which is proved above. Hence, by DF is equal to GF, and E is the midpoint of AD. E is the midpoint of DA. E is the midpoint of DA, which is given. So therefore, we can say therefore EF is parallel to AG, and also EF equals to half of AG. EF equals to half of AG by using the midpoint theorem. By using midpoint theorem. By using midpoint theorem, and also we can see that AG equals to AB plus BG. AB plus BG. And that will be also equal to AB plus CD. B plus CD. Since CD is equal to BG, which is proved above. It is proved above. So hence, and if EF is parallel to AG, it means that EF is parallel to AB also. So hence I can say that EF is parallel to AB and EF equals to half of AB plus CD. So hence proof. That's all. So now here it has been told that prove that the line segment joining the midpoints of the diagonals of a trapezium is parallel to the parallel sides and also equal to half their difference. So let us draw a trapezium. Trapezium which is ABCD. Trapezium which is ABCD. And we draw its diagonals. And their midpoints are suppose E and F. So we have to show that the midpoints, the line segment joining the midpoints EF is parallel to the parallel sides and it's equal to half their difference. So it means hence here it is given that in trapezium ABCD, AB is parallel to DC, and obviously AD and BC are its non-parallel sides. And E and F are respectively the midpoints E and F are respectively the midpoints of the diagonals, AC and PD. Now here we have to prove the first part is EF is parallel to AB, which is also parallel to CD. And second part is we have to prove that EF equals to half the difference, means half of AB minus CD. That we have to prove. Now here we will do one construction, that is we will join DE, and we will extend it to intersect AB at G. So here we will write one construction, which is the line segment DE is drawn. The line segment so here the line segment DE is drawn and extended to meet AB at G. Meet AB at G. So now we will write the proof. So here we will say that now here see that in triangle AEG and triangle CED, we have that angle AEG that is equal to angle CED. Since vertically opposite angles are equal, since vertically opposite angles are equal, so this is equal to this, and obviously and CE equals to AE, since E is the midpoint of AC. E is the midpoint of AC, which is being given only. E is the midpoint of AC. And an angle GAE that is equal to angle DC, means this angle equal to this angle, means angle GAE that is equal to angle DCE. Since alternate interior angles are equal, as it is given that DC is parallel to AB, and obviously this AC is the transverse. So alternate interior angles are equal. So therefore we can say that triangle AEG is congruent to triangle CED. Triangle CED by, we have used two angles and the included side. Two angles and the included side are equal. So therefore by ASA rule, these two triangles are congruent. Therefore AEG is congruent to CED by ASA rule of congruency. ASA rule of congruency. So we can say that first thing is CD equals to AG. CD equals to AG, which is by CPCT, and also DE is equal to A. D is equal to G. DE is equal to G by CPCT. So now therefore in triangle DGB, E and F, E is the midpoint, or E is the midpoint of DG. E is the midpoint of DG. Since it is proved above, as you can see, D is equal to G, which we have shown. So hence it is proved above. And F is the midpoint of DB. And F is the midpoint. F is the midpoint of DB, which is given. F is the midpoint of DB, which is given. So therefore, I can say that EF is parallel to GB and EF equals to half of GB by using the midpoint theorem. By using midpoint theorem. Using midpoint theorem. And also we can see that this AG plus GB is equal to AB. AG plus GB is equal to AB. Which means AG we have proved that is equal to CD. Yeah, so CD plus GB that is also equal to AB. Since CD is equal to AG, which we have proved above, So therefore I can say GB is equal to AB minus CD. AB minus CD. So hence we can say that now EF is parallel to GB. It means that EF is parallel to AB also, and AB is parallel to DC, which is given only. So hence I can say that EF is parallel to AB, which is again parallel to DC, and also EF equals to half of AB minus CD. AB EF equals to half of AB minus CD. So hence proof. Hence proof. So hope all of you understood the solutions of these two questions, 13 and 14. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. So thank you everyone. Bye.